Hi there, in today's quick lesson we're just going over how to obtain measurements in the lab and how precisely you should be reporting them. I often have students asking me what they should round their data points to, and it really does depend on the instrument because you want to report your data as reliably as possible or as precisely as possible. You don't want to sell yourself short if you can actually report it more precisely, but you also don't want to be overconfident in your data and report it more precisely than you can actually read it, because then you're almost falsifying how reliable you know those values. So, like I just said, it does depend on the instrument and what the scale is on that instrument, not scale like the kind you weigh things on, but the scale, like if you're looking at a ruler, what each of those little lines mean, or if you're looking at a graduated cylinder, what each of those lines represent. And so in general, you look at what you can reliably read with those lines, and then you estimate one more place value, and then that would be what you round to. If the measurement is exactly on the line, then you want to indicate that it is exactly on that line, and you would add one more significant zero to the end of your measurement. And then finally, digital instruments, because you can't actually see the scale and it just gives you a very specific number, you just report that. You cannot estimate on a digital scale. So for example, if you were using a balance and it said something was 3.5 grams, then you would report that as 3.5 grams. So, first one here, we are looking at the volume of a liquid in two different pieces of glassware. So on the left, we have a beaker. You can see it's going up by the even, I don't know what it's called, but 20, 40, 60, 80. But you can also see that there's a line in between each of those. So each of those lines is going to represent 10 milliliters. So that means if we were to estimate one more place value, then we would be rounding to the nearest ones place on the beaker here. So looking at this, we can see that it is over 40 milliliters, but it is under 50 milliliters. So that's what we can reliably read. So I want to estimate one more place value. So looking at this, I don't know, looks like maybe it's 44 milliliters. Your estimated value, your last significant digit, it might be different than your lab partner's just because that last value is an estimation. And then looking on the right, we've got a graduated cylinder here zoomed in. You can see that each of these graduations represents 1 milliliter. We know that our data is somewhere between 36 and 37. And just keep in mind, when you are recording the volume on something of a graduated, in a graduated cylinder, it's like a long tube, and especially with something that is water-based with the cohesive properties of water, you'll notice that it might start to rise up and stick to the edges a little bit. Do not read the edges. You want to read the bottom of the meniscus. So this middle part, you want to get down eye level with your graduated cylinder on a flat surface and read it that way. So we know that this is somewhere between 36 and 37 milliliters, so we want to estimate one more place value, and I think this looks like 36.5 milliliters. So you can see that graduated cylinders are best for measuring the volume of liquids because you can get a much more precise value, whereas the beaker on the left, it's more just for estimates or kind of just eyeballing approximately how much you'd be using. Next, we are looking at length. We've got a pencil here, and we have a centimeters ruler. So I'm going to take a look at this. We can see that it is exactly 7.5 centimeters. Each of these lines represents a tenth of a centimeter, so that means that I should be rounding my final answer to the hundredths place value. And if it's exactly on the line, if it's exactly on that 7.5, we are going to put one more significant zero. Okay. One more example. Notice that each of these, it's the same idea. I know it's super blurry. Each of these is still a tenth of a centimeter, but notice my arrow here. If you had a measurement that was exactly on 14, then you would actually add, because you can say this is exactly on 14, so that's what you can reliably measure, but you need to do one more place value, which is your estimate, so 14.00 centimeters. Looking at these lines, each of these is 1/10, so that means you go to the nearest hundredth when you are recording your final measurement. Looking here, we have a triple beam balance. With the triple beam balance, we're not going to use them a whole lot, but in case I'm short on scales, then we might be using them. So you start at the largest, so the hundreds value, so we can see that it hasn't even made it to 100, so we don't have to worry about that. Next, so that was step 1. Step 2, read the one that goes to the tens. So it is somewhere between 10 and 20, and remember we're in grams, so somewhere between 10 and 20 grams. Looking over here next, so that's our step 3, and you can see that it is 19 point, let's see, each of these lines represents a tenth, so you want to go to the nearest hundredth. So we can see that it is at least 19.0, but we want to estimate one more place value, so I'm going to say 19.0, I don't know, maybe 3 grams. So this one we are also going to the nearest hundredth. Looking at these thermometers here, thermometer A, each of these lines, we can see this is 16, this is 18, so that must be 17. So each of these lines represents 1 degree Celsius, so that means we want to go to the nearest tenth. And so this is looking about 16 point, maybe 5 degrees Celsius. And then this one down here, notice that this is 16, that's 17, and then each of these lines represents a tenth, so that means you want to go to the nearest hundredth. So looking here, we can see 16.1, 2, 3, 4. So we can reliably see that it's at least 16.4. And then we want to estimate. So I know you can't like zoom in on your papers, but that looks like about maybe like 0.6 or 0.06 degrees Celsius. So a couple reminders, look at what each of the lines represents. So if each of the lines represents 1, go to the tenth. If each of the lines represents a tenth, go to the hundredth. So just keep that in mind, estimate one more place value, and don't forget your units. You have to make sure that you're using either degrees Celsius or grams or whatever it is that your unit is on your instrument. Okay, don't forget those. And that is it. Let me know if you have any questions.